Hello friends and welcome to YouTube channel Freedom Tech, and in this session what we are going to learn. In this session we are going to create our own custom object detection model which detect small plants, and we are going to basically create a counter for all these small plants. So let me show you what is basically our project. So I have here a video file, and here it is. As you can see, there is a small plants, this one, then this one, then this one, then this one. So this is basically drone video file. Here it is. As you can see, drone is continuously flying on the top, and we have here some plants, this one, this one, this one, this one. So our goal is to first create our own custom model with the help of yolov10, which detect all these small plants. Then we are going to use our tracker. So our tracker will track all these plants again, and it will assign unique ID for each plant. Means for this plant we have now unique ID. For this plants we will have unique ID. For this plant we will have basically a unique ID. So when we have our own unique ID for each plant, so it is really easy to create a counter. So this is what our today's project. We are going to create our own custom model with the help of yolov10. Then we are going to track all these plants. We are going to assign the ID for each plant, and then we are going to create a counter. So let's get started. So before we start our practical, friends, if you learned something from our videos, please consider to subscribe our channel. Okay friends, thank you so much, and let's get started. So friends, first simply we are going to create here our own virtual environment for yolov10. So let's just open a download folder, and here just create a new folder, and we are going to mention our folder name as a plant because we are working with plant project. So let's just say plant. This is what our directory folder. So friends, this is what our plant folder, and inside that folder we are going to create our virtual environment for yolov10. So let's get start. So first for virtual environment we are going to open our Thony Python IDE. So Thony Python IDE, let's just open Thony Python IDE, and then we are going to go here in run config interpreter, and then just click on new virtual environment, click on OK, go to the downloads, and this is what our folder which we just create, and here inside this folder we want to create our virtual environment. So just select the plant folder, select folder. Now it's creating virtual environment, as you can see. Done. So click on OK. Now as you can see users feed downloads plant scripts and python.exe. So plant is our folder, and we successfully create inside a plant folder we create our virtual environment. So if you open the folder which we just create plant, and inside that, as you can see, the requirements folder and files for virtual environment. So now we have done with virtual environment. So we are going to simply download our today's project repository. I will mention the link inside description box. You need to simply copy paste the link inside the web browser. So yolov10 plants counting. Just go to the code, click on download zip, and it will download zip format repository. So we successfully download our repository. Just open downloads folder, and this is what our repository. As you can see, right click, WinRAR, extract as a folder name. It will extract our repository as a folder. Go inside the folder, again same folder. Now first we want to install yolov10 inside our virtual environment. So for that we need a text file, imp.txt. just open it, and here we have our yolov10.git. This is what our repository for yolov10. So we want to clone our yolov10.git directory. So just copy the link, but first what we want here, just open our Thony, and let me go here first, edit, clear the shell, and now we are inside our virtual environment. So let's just open here tools, open system cell, and we want to go inside our plant folder. So for that, just open downloads, downloads, and go to the plant folder and go here, plant, right click, copy the address, open the system shell which we have opened, and just paste it. The path which we copied, basically this is the folder path, the plant folder path, and just mention cd space, paste the folder path from here. This is what our folder, click on it, go here, right click, copy address, and we open our system shell with the help of Thony. From here, tools, open system shell, it will open our system shell, and paste the path and just mention cd. We want to go inside our plant folder, so then just hit enter. Now we are inside our plant folder. Now we are ready, and here we want to run our repository, our yolov10 repository. So go inside the folder yolov10 plant scouting main and imp.txt. This is what our link, as you can see. Just copy the link, copy it, open our system shell and just paste it and then hit enter. It will clone yolov10 folder, or you can say it will clone yolov10 repository. So we have done. Now we are ready. If you go here in folder, downloads, and then plant, as you can see we have now yolov10 folder. So we want to go inside the yolov10 folder, and here we have requirements.txt which we are going to run with the help of pip install, and it will install yolov10 inside our virtual environment. So open system shell, and right now we are inside plant, so we want to go inside yolov10 folder. So run again cd space yolov10 and then hit enter. Now we are inside yolov10, and here we are going to run our requirements.txt file. So pip space install space -r and requirements.txt, and then just hit enter. It will install yolov10 only for our plant folder, our virtual environment. So as you can see, now it's installing yolov10. So here friends, it will take some time for FFmpeg. So meanwhile I will pause video. So friends, as you can see, we have successfully completed our installation process, and we successfully installed yolov10 for our virtual environment. So we have done with yolov10 installation process. Now just close system shell, and now again we want to go inside our repository which is yolov10 plants counting main. We successfully done with yolov10 installation process. Now we want to create our own custom model for detecting the plants. So go inside our repository yolov10 plants counting main, same folder again. So first we need video file, and then we need images which I have already trained with the help of label img software. So in download.txt, this is what our text file. Here I have mentioned the images.zip file, and inside that images.zip I have already draw a rectangle with the help of label img for object detection. So means I have already trained the images, I have already trained the data set with the help of label img software. So we only want to download our freedomtech.zip file. So just copy the link, images, here it is. As you can see, I have mentioned the images.zip, and this is the link. In front of the images.zip, this is the link. So just copy the link, copy it, open browser, open new tab, and just press Ctrl+V, hit enter. It will open Mega Cloud link. As you can see, now simply we are ready. We are going to click on download button, and it will download our freedomtech.zip file. Meanwhile, we need our video file also. So here it is. As you can see, the next link is basically for video file. So just copy the second link, copy it, open new tab, same way Ctrl+V, it will paste the link of our video file, and as I mentioned, this is what our video file. Click on download, and it will download video file also. So friends, we have successfully downloaded our freedomtech.zip file also our video file. So let me close all these links, and now if you go let me close the text file also. If you go inside downloads folder, here it is. As you can see, we have our video file, and then we have our freedomtech.zip file also. So both files we want to copy paste inside our yolov10 plant scouting main folder. So just select it, all those files, copy it, go inside yolov10 plant scouting main and just paste it over here. That's it. So as I mentioned, freedomtech.zip is ready to use dataset which I have already trained with the help of label img software. So we are ready, and we want to upload this freedomtech.zip on our Google Drive. So let me open my Google Drive first. So friends, as you can see, I have opened my Google Drive, and here we want to upload our freedomtech.zip file. So just click on new, then go to the file upload, then go to the downloads, and our repository yolov10 plant scouting main, same folder again, and our file which is freedomtech.zip. Just select it, click on open, and it will upload our freedomtech.zip on Google Drive. You have to open your Google Drive and just upload freedomtech.zip file on the Google Drive. So meanwhile, we are going to upload our Google Colab for training purpose. So just I have opened Google Colab, then click on upload, go to the browse, downloads, and our repository yolov10 plant scouting main, same folder again, and this is what our Colab file for yolov10 custom object training. So just select it, click on open. Now it will upload our Google Colab file on our Google Colab. So friends, as you can see, I have successfully uploaded our file, our Google Colab file on our Google Colab machine. Now here we want to go inside runtime, change runtime type, select Python 3, select T4 GPU, click on save button, and then just click on connect. So friends, as you can see, we have successfully connected. Now we are going to run our cell one by one. So let's just start with first cell, import OS. Done. Now we are going to clone our yolov10.git folder again, and then we are going to download yolov10 n.pt model, and then we are going to download yolov10 s.pt model. You can use any one of them model, but for today's session we are going to use here yolov10 s.pt model. So let's just start our second cell. So friends, we have done with second cell. Now we are going to import our models from Ultralytics import YOLO. Just click on next cell. Done. Now just scroll down. Now we are going to cross check if our yolov10 is perfectly installed or not. So for that we are going to detect the object with the help of RoboFlow online image, which is doc.jpg. So just run the next cell. Done, and result is saved inside runs detect predict. So if you just click on this small folder icon, go to the runs, then we have detect folder, then we have predict folder, and inside that we have doc.jpg. Just double click on the image, and here it is. As you can see, the rectangle, it means we successfully detect the object with the help of yolov10 s.pt, our by default pre-trained model. Now we are ready, and we successfully upload our freedomtech.zip also. So here it is. As you can see, one upload completed. Now we are going to mount our Google Drive on our Colab machine. So just run the next cell, click on connect to Google Drive. Here we want to select our Gmail ID, click on continue, scroll down, again click on continue, and now it will mount our Google Drive. So friends, we successfully mount our Google Drive. Now simply we want to create a dataset folder, and inside that dataset folder we are going to unzip our freedomtech.zip file. So let's just run our next cell. It will create datasets folder, which is new folder, and inside that folder it will unzip our freedomtech.zip, and inside that freedomtech.zip we have all the data. So here it is. As you can see, we create datasets folder. If you click here, we have freedomtech file. We basically not file, we have freedomtech folder, and inside that folder we have images and labels folder, and inside that we have our all the data set. So now here we want to create a data.yaml file. So freedomtech folder, just click on these three dots, click on new file, and here we want to create a data.yaml, hit enter, it will create data.yaml file. Just double click on the data.yaml, it will open our file as it is. As you can see, this is an empty file. So we want to paste the code from our repository. So again, go to the downloads, our repository yolov10 planes counting main, same folder again, and inside that I have mentioned data.txt file, text file. Copy the code as it is, copy it, open our browser, data.yml file which we open, and here we want to simply paste. Let me check here again, just copy data.yml, let's just press Ctrl+V. Yes, it's paste. Now here we want to mention our class name, which is plant, and number of class, of course, only one. Now we are going to save our data.yml, so press Ctrl+S, save, and just close data.yml. Now we are ready, and we are going to start our training with yolov10 s.pt pre-trained model with 100 epochs, image size 800. So let's just click on our next cell. So friends, as you can see, it started our training 1 out of 100. So it will take some time. Meanwhile, I will pause the video. So friends, we completed our training process, and our model is saved inside runs detect train folder. So go to the runs, then detect train folder, then inside that we have weights folder, and then we have best.pt. This is what our model. So just click on it and click on download. It will download our best.pt. So friends, we successfully download our model. So let me open our downloads folder, and here it is, as you can see, best.pt. So we successfully download our best.pt model. So now let's just close the browser. Now what we are going to do, let me open here new tab and again go to the downloads, and here this is what our first tab and this is what our second tab. So from first tab, this is what our model best.pt, this is what our model. So we want to move our model inside our virtual folder where we have our yolov10 environment. So best.pt, right click, cut, go to the plant folder, then inside yolov10 folder we have our files of and folder for yolov10. So here we want to paste our best.pt. So as I mentioned, just copy, or we can say just cut the best.pt model for downloads folder, just open the plant folder which is our virtual folder, then inside that we have our yolov10 folder, and here we want to paste our best.pt, our own custom object detection model. So now again go to the downloads folder, and we have our yolov10 plants counting main repository where we have our all the files for this project. So again same folder. So from this file we need our video file, we need our Python code, also we need our tracker file. So let's just copy all these things and paste inside our yolov10, our virtual folder. So tracker.py, select the tracker.py, Python code main code.py, then our video file drone tree count.mp4, right click, copy all the things, go to the yolov10, we are inside here download plant yolov10 where we have our virtual environment for yolov10. Here we already copy paste our best.pt model. Here just paste all the things, our video file, our Python code, and our tracker.py. Done. Now here we want to create coco1.txt, our label file for our custom object detection. So right click, new text document, and mention the name coco1, hit enter, open it and mention our class name which is plant. We have only one class, plant. Go to the file, click on save. That's it, we have all the done. Now we are ready, and we are going to open our main code.py with the help of Thony Python IDE. So here let's just cross check, go to the run config interpreter, and we select our plant folder. Here it is, as you can see, C users free downloads plant script python.exe. This is what our virtual environment. Click on OK. Plant script python.exe. So just close the untitled file, go to the file, click on open, go to the downloads, our plant folder, then inside that we have yolov10, and inside that we have our main code.py. And here we want to install CVZone, so go to the tools, manage packages, and CVZone. Hit enter, CVZone, click on install, it will install CVZone. Done. Now we are ready. We have all the done with Ultralytics, and we have all the done with yolov10 also. So now just scroll down. Here it is, as you can see, I have already mentioned the best.pt, our model, and then we have our video file, then we have our coco1.txt file. Then because we are going to draw here a line for counting purpose, so we need x and y coordinates, starting xy coordinates and ending xy coordinates for drawing the line. For that we need mouse event move function. So here this one is basically cv2.event mouse move function. When we move our mouse on the frame, we will get xy coordinates, and with the help of xy coordinates, it is really easy to draw a line, which we are going to use for counting. Simple. So then I have already mentioned the full code. So this is what our basic code here it is, as you can see. We detected object, we have x1, y1, x2 and y2. So here we are going to detect our plants, and then now we have our x1, y1, x2, y2, our rectangle coordinates, our object detected rectangle coordinates. So now we can simply use our tracker. So for tracker, we want to send our object detected rectangle coordinates. So for that, list.append, we are going to create our list, and inside that we are going to pass x1, y1, x2 and y2, which is our object detected rectangle coordinates, and this list we are going to call here list. And then with the help of tracker, we are going to send our all the coordinates to our tracker, and tracker will again track our object, and it will assign the new rectangle coordinates. Also it will assign the ID for each plant. Simple. And then we need a center point for each rectangle. So this is the center point method. Cx is equal to int x3 plus x4 and cy is equal to int y3 plus y4 divided by 2. Simple. And then let's just first start with our tracking and object detection purpose. So let me comment next code, where we have basically our counter. So this code we are going to update, but first we are going to only stay with our object detection and our tracking. So here we have our center point. So we have here cv2.circle method. Then we are going to put ID as a text on our top left corner rectangle, and then we have our rectangle. Now save the code, and if I run the code, let me cross check here. I have mentioned the 0 means it will freeze our frame. It will start with 1 by 1 frame. So here it is, as you can see friends, we successfully detecting the plant, and we have our rectangle, we have the center point. As you can see, the blue color is basically the center point for each rectangle. Also with the help of tracker, we are assigning unique ID for each plant. For this plant we have 0, for this plant we have 1, for this plant we have 2, for this plant we have 3, for this plant we have 5, this plant we have 6, for this plant we have 4. So if you skip the frame one by one, it will detect each plant. So we have rectangle. Then with the help of tracker, it will assign a unique ID. Also we have blue color center point. So we have done with object detection, we have done with tracking. Also we have our center point for each plant. Each rectangle there is a blue color center point. Simple. Now as I mentioned, we are going to use here cv2.line method. So we have here cv2.line method, and as I mentioned, for drawing line we have here our cv2.mouse move function, cv2.event mouse move function. So simply Let me start the code because I have already draw the line. So you will see the line on the frame. Here it is, as you can see, this is the line. So simply if you move your cursor over here, you will get the coordinates 1481 and here 10181480. So the coordinates, simply with the help of CV2 event mouse move function, you will get CV2 dot line starting point and ending point. Here it is, I have mentioned 2480 and 1018480. Remember one thing here, we want to mention y coordinates same. So if this one is 480, so end point y coordinates also we want to mention same, 480 480. Then this 480 we are going to mention as a cy1. Here it is, as you can see, cy1 is equal to 480. This y coordinates, end point y coordinates and start point y coordinates for drawing line. So 480 is basically our cy1. Then offset 8. Then we are going to create here a list. So now we have our line. So with the help of line, we are going to create a condition. So if each plant blue color center point, when it will touch our line, then we are going to count our plant. Simple. So for that we have this condition. If our cy1, this cy1, if our cy1, if it is less than cy, this center point plus offset, and cy1 if it is greater than cy minus offset, then only we are going to detect our object. Then we have our ID. So means when we detect our plant, means when plant center point touch our line, red color line, then we are going to send our ID inside our plant count list. And then because of it will take some time, so meanwhile it will count same ID and again. So for that we create here a condition. If plant count dot count ID is equal to 0, means please don't count same ID again and again. Then it will save the ID inside our list, and then we have our counting variable. So counting variable is basically length of our plant count list. Plant count list is basically our counter. So then we are going to put our counter on the frame. 1560 is the coordinates. Simple. Now we are ready, and here I will mention first it will show all the detection and tracking, and then when it will touch the line, when the blue color center point touch line, the rectangle, after that the rectangle color will be changed 255. Simple. So let's just start. First let's just go with frame by frame, then I will start a while loop. So here it is, as you can see, right now the rectangle is green because the center point is not touching our line, which is red color line. So here watch, this rectangle is right now green, but when the blue color center point touch our line, it will become a red and it will increase the counter. So let's just press space button from the keyboard, it will go with one by one frame. So I am pressing space button. So here watch, as you can see, this blue color center point touch the line, the rectangle become red color and the counter is increased. Means we count here one plant. Next frame. Now watch here, this rectangle become red, the counter is increased. We count two plant. Watch for this one, is right now green. When the blue color center touch the line, it will become red. Plant count 3. We count 3 count. So this is how it will increase the counter. As you can see, I am skipping the frame one by one because we freeze our frame. Just press any button from keyboard. So I am pressing here space button. So here it is, as you can see, it's increasing the counter. Now we are going to start our while loop. Now watch. Now watch. 1 2 3 4 5 6 7 8 9 10 11 12 13 14. So it's perfectly counting each plant. We successfully create our own custom object detection model with the help of yolov10. We assign the unique ID with the help of our tracker. Then we have our cv2.line method, and we create the condition if the each plant center point touch our line, then we have our counter. So it's perfectly working. I mentioned the full code inside our repository. I hope you will learn something from this video. We'll meet our next video. Till then, thank you, take care, and bye bye.